One of the most overlooked realities of aging is the gradual decline of the immune system, a process scientifically known as immunosenescence. This biological phenomenon is the primary hidden reason why older adults experience more frequent colds, flu infections, and other respiratory illnesses. While many people attribute this vulnerability simply to getting older, the underlying cause is far more complex. This vulnerability of catching colds, flu, and infections is attributed to deeper-rooted in cellular and molecular changes within the immune system. As individuals age, both the innate or first-line defense and adaptive or targeted immune response systems become less effective. This decline reduces the body's ability to recognize, respond to, and eliminate pathogens such as viruses and bacteria. Immunosenescence refers to the progressive deterioration of immune function with age, affecting nearly every component of the immune system. These changes significantly impair the body's ability to recognize, respond to, and effectively fight infections. Key changes in immunosenescence include reduced production of T cells, which is critical for killing infected cells, decline in B cell function, leading to weaker antibody responses and impaired communication between immune cells. These changes significantly reduce the body's ability to fight infections. Research shows that immunosenescence is a major contributing factor. As a result, increases in susceptibility to viral infections emerge, including influenza and other respiratory viruses.
Immunosenescence refers to the progressive deterioration of immune function with age, affecting nearly every component of the immune system. Normal antibody production. In younger individuals, the immune system produces high-quality antibodies that efficiently neutralize pathogens. Weakened antibody production. Aging reduces the quality and effectiveness of antibodies produced by B cells. These antibodies are less efficient at neutralizing pathogens, leading to increased infection risk, longer illness duration, and reduced vaccine effectiveness. Slower immune response. The immune system in older adults responds more slowly to invading pathogens. This delay allows viruses to replicate before the body can mount an effective defense. Chronic inflammation or inflammaging. Aging is associated with chronic low-grade inflammation, which disrupts immune balance. This condition weakens immune efficiency, damages tissues, and increases vulnerability to infections. Reduced physical barrier defenses. The body's protective barriers, such as the respiratory lining, become less effective with age. This allows viruses to enter the body more easily and increases infection severity.
Another critical hidden factor and one of the most underestimated contributors to frequent illness in older adults is sleep deprivation or poor quality sleep. Scientific evidence shows that sleep is essential for immune regulation. Adequate and restorative sleep. Adults typically require 7 to 9 hours of quality sleep per night for optimal health. Sleep supports brain function, hormonal regulation, and immune system performance. Chronic sleep deprivation is linked to increased risk of obesity, cardiovascular disease, and cognitive decline. Another condition that leads to frequent infections is chronic low-grade inflammation or inflammaging. Inflammaging is chronic and produces low-level inflammation. This condition is characterized by persistent activation of the immune system, even in the absence of infection. While inflammation is essential for fighting infections, chronic inflammation damages healthy tissues, disrupts immune signaling, and weakens overall immune efficiency. Paradoxically, this means the immune system is both overactive and ineffective at the same time. Another condition in the reduction of immune defense is reduced barrier defenses. These are the body's physical barriers, such as the skin, respiratory lining, and mucosal surfaces. They can also weaken with age. These barriers are the first line of defense against pathogens. In older adults, mucociliary clearance in the lungs declines. These conditions further impair immune function and increase susceptibility to infections. According to the CDC, underlying health conditions significantly raise the risk of severe illness from respiratory viruses. Reduced vaccine effectiveness. Vaccines rely on the immune system's ability to generate a strong protective response. However, due to immunosenescence, vaccine responses are weaker, protection may not last as long, and booster doses may be required. This is why older adults are often advised to receive high-dose or enhanced vaccines, particularly for influenza. Slower recovery and increased complications. Not only do older adults get sick more frequently, but they also take longer to recover. A weakened immune system means slower viral clearance, prolonged inflammation, and greater risk of complications such as pneumonia. Even a mild cold can escalate into a serious condition in older individuals. So the hidden reason older adults experience frequent colds and flu is not simply age itself, but the biological transformation of the immune system. So in our discussion, we discovered that immunosenescence combined with chronic inflammation, reduced immune cell function, creates a perfect storm that increases vulnerability to infection. However, it's not all doom and gloom, because this decline is not entirely unavoidable. Scientific evidence suggests that lifestyle factors, such as healthy nutrition, physical activity, vaccination, along with boosting vaccination and quality or restful sleep, can help support immune function and reduce risk. Understanding these mechanisms empowers individuals to take proactive steps toward maintaining immune resilience, even in later life. And if you enjoyed this video, please consider giving it a like.